Thank you everyone for joining us. Today we are going to give an update on some CLSI breakpoints. So if any of our microbiology colleagues are on the call, thank you for joining us and thank you for supporting our stewardship work. Today it's gonna be me and Chris. I'll let Chris give an intro and then we will get started.
Okay, thanks very much, Samaya. So next slide, I think, or can I advance slides?
I can do it for you.
Okay, so we have a few objectives for this particular 50-minute presentation. There were some new updates in 2023 from CLSI about breakpoint changes for aminoglycosides, some of the beta-lactams, and then fluoroquinolones. And so we want to address those and make sure that everybody is knowledgeable about those breakpoint changes. And then we'll talk a little bit about how these changes in the breakpoints is going to impact the care that you provide to your patients at your institution, and how we might be able to help with operational workflows for different individual institutions. So next slide. So let's talk a little bit about breakpoints. So the Clinical Laboratory Standards Institutes, or CLSI, is one of the institutions that creates and validates breakpoints for antibiotics, as well as against different organisms. And CLSI actually has different working groups. They have a mycobacteria working group, a fungal working group. They have an antibiotic susceptibility testing working group, and an anaerobe working group. And so the end point of the committee for antibiotic susceptibility testing is to set breakpoints. And the breakpoints are somewhat controversial because the MIC is somewhat, it's just a point in the range of which you would see an organism being susceptible and things. So UCAST is the committee that produces breakpoints over in Europe, and USCAST was formed in 2013 to have the U.S. have a voice in the UCAST process, because we're all in one world, and we're all fighting the same types of organisms that are developing resistance. So next slide then. So how do you set breakpoints? So there are three main bodies of literature that are looked at in order for you to set breakpoints. The first one is the microbiological distributions. And so you have phenotypic antibiotic susceptibility testing, where you test a large number of wild type organisms of a single species, and you get a distribution for MICs. And so that's the wild type distribution. And so it's unique to that organism and that antibiotic combination that's being tested. And so when you perform antibiotic susceptibility testing, you're trying to determine whether the isolate that you have in your hand is somewhere within the wild type MIC distribution. And so none of those have any intrinsic phenotypic resistance. All right, so I'll give you an example. So we know that Klebsiella pneumoniae is intrinsically resistant to ampicillin. So if you were to test Klebsiella pneumoniae with ampicillin, you would get a very high MIC, like 64, for example, 64 milligrams per liter. So that is not something that we can safely give in patients to get some type of activity. And so, so we know that Klebsiella is intrinsically resistant to ampicillin, and so you don't even need to test it necessarily. All right, so that would be one set of data that's looked at for breakpoints. The second set would be the pharmacokinetic and pharmacodynamic literature looking at tissue concentrations and mostly mice studies and in vitro hollow fiber systems. And so you basically look at those to determine what types of concentrations are you going to get at different tissues. And then the final set of data that you want to look at is clinical data. And so that basically looks at what's the best dose and interval that we can use safely to inhibit that organism. And so there's been lots of changes. So the CLSI is the one that primarily sets the breakpoints, but also if you're using an automated antibiotic susceptibility testing system like a Vitec or a microscan or something like that, the FDA also sets breakpoints for those automated systems. And fortunately, in most circumstances, the FDA and the CLSI have similar breakpoints, but there are some that are different. And so if you use an automated system, you have to use the FDA breakpoints. You can't use the CLSI breakpoints unless you do some validation studies in the micro lab to validate your MIC that you're going to report to your facility. So next slide. So why do we need to change breakpoints? So a lot of this has to do with the Marino trial and what happened in the post hoc analysis in the Marino trial. And so the CLSI is made up of a group of infectious disease pharmacists, physicians, microbiologists, and they come together and twice a year annually review a bunch of data. And they look at those three sets of microdata, PK/PD, and clinical data to come up with whether or not changes have to be made. And so right now, the intermediate category encompasses three distinct meanings. And so sometimes they'll change the meaning of the intermediate category. And so sometimes the intermediate category is just based off of uncertainty in an MIC result due to the technical variability inherent in the testing. So if you took an organism antibiotic combination and you tested it like 10 times, 10 separate tests, you might get 10 separate results in the MIC. Hopefully you don't get that much, but you could get a range of results, and that's because of the variability inherent in the testing. And then also You look at the potential for favorable clinical outcomes if higher drug dosages are given to patients, and whether or not the infection is at a site where the drug concentration concentrates well. And so we use like urine a lot because a lot of antibiotics concentrate very high concentrations in the urine versus cerebral spinal fluid, which maybe not a lot of not a lot of antibiotics will get into those or into that site. Okay, next slide. So here's one of the breakpoint changes that occurred in 2023. They looked at aminoglycosides in the breakpoints, and for Enterobacterales or any of the gram-negative isolates, they lowered the aminoglycoside breakpoint. So by lowering it, then more of the organisms would be in the susceptible category, and you'd be able to define the organisms that are susceptible compared to the organisms that are resistant. For Pseudomonas, a big change occurred where they deleted gentamicin for Pseudomonas infections from a variety of different reasons. Some of it microbiologic, some of it PK/PD, and some of it was because of clinical data. And so that's going to be a big change for a lot of different healthcare institutions because most people are doing gentamicin level monitoring, and if they have a Pseudomonas infection, the lab won't report gentamicin anymore. They also lowered the tobramycin breakpoint, and the amikacin breakpoint is only going to be reported if the organisms comes from the urine. So certainly those are some big changes. So next slide. So this particular slide basically looks at gentamicin, tobramycin, and amikacin for Enterobacterales and then for Pseudomonas. So going across the top, then you have the updated CLSI criteria in the M100 33rd edition book. And so you can see that compared to the previous one, you have gentamicin is less than or equal to 4 is susceptible. Now it's less than or equal to 2 if it's Enterobacterales. Intermediate is less than or equal, or is actually 4. And now resistant is greater than or equal to 8. And then tobramycin also was lowered. And also amikacin was also lowered from 16 to 4, and intermediate from 32 to 8. And then resistant is from greater than 32 to greater than or equal to 16. So that's for the Enterobacterales group of organisms. For Pseudomonas, then, there is no reported gentamicin susceptibility categories. Tobramycin is less than or equal to 1, so it's a 4-fold reduction in the susceptibility pattern. 8 is intermediate, now it's 2, and then greater than or equal to 4 is considered resistant. And then amikacin is just for infections from Pseudomonas that originate in the urinary tract. And so if you have a sputum with Pseudomonas, they won't report, the microlab won't report the amikacin susceptibilities. Okay, so next slide. Okay, so the revised breakpoints for piperacillin tazobactam was something that evolved from the Marino trial. And there was a post hoc analysis of the Marino trial that revealed very major errors for piperacillin tazobactam when local labs were using commercial antibiotic susceptibility testing devices. And so those errors occurred in isolates from E. coli or Klebsiella that produced the CTXM extended spectrum beta lactamase, as well as a narrow spectrum OXA1 beta lactamase. And so the commercial antibiotic susceptibility device was able to pick up the CTXM for the extended spectrum beta lactamase, but it didn't pick up the OXA1. And so there were patients in the study that received piperacillin tazobactam despite bacteremia with isolates that were classified as resistance by the reference microbroth dilution antibiotic susceptibility testing. So that had a major impact in the results of the Marino trial. And so those were some of the microbiological results that led to piperacillin tazobactam breakpoint changes. And there were some clinical data, obviously, from the Marino trial that showed that if patients received the drug and had MICs that were greater than or equal to 32/4, they had an increase in odds of 30-day mortality compared to patients with pip/tazo MICs that were less than 16. And so that was some of the clinical data that led to this change. And so for Enterobacterales, you can see that the susceptibility is now less than or equal to 8/4. For it's no longer intermediate, it's susceptible dose dependent. The MIC is 16/4. And then resistant is considered greater than or equal to 32/4. And then for Pseudomonas, it's virtually the same as it was previously. Maybe some little differences in the resistant category. All right, so the next slide then. So due to these cutoff, CLSI is recommending that pip/tazo should be given as an extended infusion. And there's probably lots of places that are giving piperacillin tazobactam over a half an hour. And so the rationale for the extended infusion is to maximize the time above the MIC to optimize the bacterial activity. And so this would be for pathogens with an elevated MIC, because the difference between the epidemiological cutoff value for piperacillin tazobactam and some of the Enterobacterales may have some may not be separate from each other very well. And so they are recommending 4.5 grams every 6 hours over 3 hours. And that should be utilized for any severe infection or if you suspect Pseudomonas in your patient. So there's going to be lots of differences that are going to be needed for this. You're going to have to update some of your electronic order sets for pneumonia and bacteremia and sepsis, but certainly it excludes your pre-op prophylaxis.
All right, thank you, Chris, for that summary. I am going to go over what we can do and what we can adjust within each of our hospitals for patient care. So like we just discussed, the cutoffs for Piptazo have changed, so the dosing should change. Specifically, the 30-minute infusion really should not be used anymore. The 4-hour infusion every 8 hours is still appropriate, but again, if we have a severe suspected infection with Pseudomonas, we should utilize the Q6. So on this table, I just have a summary for you for how we would do the 4.5 extended infusion dosing. The first dose should still be given as a load just to get that concentration. And then after that, 6 hours later to start the extended infusion 4 hours. This is difficult operationally given the lack of compatibility with Piptazo. So understanding the operational difficulties there. And then just for impaired renal function or even on dialysis, it is almost the same dosing regimen, except it would be Q12. So still a load, still start 6 hours later, and then just the next one would be Q12. Okay. We mentioned that gentamicin has been removed, so this should not be used for gram-negative coverage anymore, like Pseudomonas, even if it's used for double coverage. So if we have an order set or a protocol where we use gentamicin, that should be removed. I'll go over other aminoglycoside options, but to summarize, tobramycin would be the most appropriate alternative moving forward. So if you have a sepsis order set, a pneumonia order set, even pre-op prophylaxis where you're covering for gram-negatives, we would want to switch out that gentamicin. If we have a need for double coverage, again, this is not for everybody, but if your antibiogram susceptibility is less than 90%, or if a patient is very critical in the ICU with a suspected Pseudomonas and double coverage is required, Gent should no longer be that option. It would be tobramycin. And if it is currently on your susceptibility reports, just to make it easier for providers and for choosing the right empiric option, it should probably be hidden just to make it a little bit easier. And then with another aminoglycoside update is amikacin. So I kept saying replace Gent with Tobra specifically because we cannot use amikacin instead of Gent. It should only be used if there is a suspected urinary source. So I just have an example here if we are looking at a susceptibility report and how we want to change it. I divided it out by if we know that Pseudomonas is from a urine versus a non-urine versus a CSF. So again, amikacin, the red is kind of the updates. Amikacin is going to, again, only be appropriate when we're talking about a urinary source for Pseudomonas, should not be used for non-urine, should not be used for CSF. Gentamicin should not be used across the board, so just the removal of that altogether. And then tobramycin would be the appropriate option if we had to use it for a non-urine, really actually non-urine, urine, or CSF. There have also been with the update, some fluoroquinolone breakpoint updates. So this is only for Cipro and Levo, where you see the cutoffs are different now. And that, because of the updated cutoffs, the dosing is also now updated. So if we're looking at a Cipro IV dose, it should be Q12. Traditionally, we have done the Q12. I'm sorry, I think I misspoke. Q8. Traditionally, we did the Q12 dosing. And then same with oral, the higher dose, 750, and then also a Q8 interval. if we're needing to use it for Enterobacterales or if it's susceptible for Pseudomonas. And then levofloxacin remains the same dosing, but the 750. All right. So with all of these updates, Chris, I know this is your slide, so I don't know if you want to go over it.
Okay, sure. So I think it's important to work with your laboratory. There's older versions of the microscan that are still being used, and sometimes because of that automated AST equipment, you might have to do a disc diffusion supplement where you drop a disc on a plate and then use that for supplemental information. And so if your lab is reporting ciprofloxacin, then you may want to suppress that depending on your organism. And there's a really good review article from Romney Humphreys in 2002 in Open Forum Infectious Disease on how laboratories are struggling with these updated breakpoints. I think her survey of different laboratories showed that there's a preponderance of labs that are not being able to use the updated breakpoints because of technological or employee relationships associated with the lab. And so you can always report a result, but not provide an interpretation from the lab standpoint. So they can tell you what an MIC is, but they won't tell you whether that's susceptible, dose dependent, intermediate, or resistant. So that's also something that some labs may be able to do until they validate their susceptibility systems in their lab.
Right. There, just want to spend the last couple of minutes talking about some organism-specific changes. This is a little bit of a summary we've already discussed, but for Pseudomonas, again, avoiding the use of gentamicin altogether. This is now considered intrinsically resistant. To summarize again, avoiding amikacin for non-urinary infections, and then not using tobramycin monotherapy. Piptazo should now be used in the extended infusion interval, like we discussed. And then one we haven't brought up is cefepime. So the standard dosing of cefepime should also be increased to the 2 gram IV Q8. If possible, obviously an extended infusion, given that it's a beta-lactam, would be a better option. For daptomycin, there are some updates with Enterococcus faecium. So with this, criteria is to only include susceptible, dose dependent, and resistant. Because of that, the dosing should be higher. So 8 to 12 mg per kg Q24 should be considered for E. faecium. For Enterobacterales, just to avoid confusion, Enterobacterales is not the same as Enterobacter. So Enterobacterales, again, aminoglycoside monotherapy should not be used for R gram negatives. If we have a severe infection with Piptazo, the Q6 over 3 hours should be used in those indications. And then the same with cefepime. So just highlighting the Enterobacterales and the Pseudomonas is very similar recommendations in the coverage as well as the dosing of the meds. And then this is just a summary of Dapto by itself on the increased dosing. I'm sorry, not extended. For Steno, The recommendation is to remove ceftazidime altogether as a treatment option. Minocycline would be our drug of choice, but again, the breakpoints here were lowered to less than 1, where it was previously 4. The susceptibility should be evaluated before using this and not using minocycline for a suspected CNS infection. Anything to add here, Chris?
Nope, I think you did fine.
All right. And then go ahead.
Okay, so additional revisions associated with the CLSI is an addition of breakpoints for the new sulbactam, durlobactam against Acinetobacter. So susceptible will be less than or equal to 4 and 4. Intermediate will be 8 and 4, and then resistance is greater than 16/4. So that's relatively new drug that may be useful for Acinetobacter species because it's seems to be intrinsically resistant to quite a few different antibiotics. Additionally, CLSI has made a comment about ceftriaxone use against methicillin susceptible Staph aureus. And basically they're stating that current data suggests that ceftriaxone may not be adequate for all MSSA infections. And so an infectious disease consult is suggested if you want to use ceftriaxone and the patient has MSSA and maybe is going home or something like that. You may want to consult infectious disease to ensure that this is appropriate for the particular site of infection and the treatment. So.
All right, and that concludes our talk on the CLSI updates. I think we have a couple of minutes for questions. All right, I am not seeing any in the chat. Thank you again to everybody. We have our email on here if something comes up. We are happy to answer. And yes, we'll share the slides and the recording.